Good morning or afternoon, depending upon when you're watching this. I hope you had little or no trouble with section 1. If you had any questions, please feel free to send me a message. Something I'm thinking of doing in the future is perhaps office hours using Zoom. That's something I'm going to try to investigate over the weekend and see if I can come to maybe a better conclusion by Monday. Okay, so for today, I just want to do 4, 5, and 6. And we're going to go ahead and jump in with number 4 here. Number 4 says, suppose E, F, and G are events in a sample space S. I'm going to go ahead and just draw a picture to represent these three circles. And you can read all those clues down through there, but I'll tell you, they have not given you enough clues to label all the parts in the picture. Normally we would start with this middle value and work our way out. We can't do that here. So what I'm going to do is instead I'm going to shade first, and then I'm going to write an equation based on the shaded region. So let's first figure out, okay, it says to find not E or F. So remember that means find not E first. So everything except E, I'll surround E real fast. And then whatever I get from the other set, which says just F, just tack it on. So you'll get this much of F, and then you'll also get this part here that was originally not shaded, and now it is. So the whole answer here is everything you see shaded. Okay, that's that boxed in shaded region. Then I said I was going to build an equation, and this is going to take a little bit of creativity on the part of you or I, whoever's doing the problem. You're going to have to look and think of a way to describe what it is that we just shaded. And if you remember, the very beginning was a lot of that was not E. So that'll be the beginning part of my equation. The second part, remember we shaded this down here into the F part. Let's see here. The F part that was not inside of E. And then so that was already stated, shaded. And then what we added was this region right here, which is E and F. Okay? Now this was made up by us. We need to figure out what those probabilities are, and actually one of them we know. If you know the probability of E, then we should know the probability of not E. We just take 1 minus 0.35 and we get 0.65. If you have a 35% chance of something occurring, you have a not probability or complement of 65% chance of it not happening. And then we'll add on this probability of E and F. If you look up into your clues, we do not know. No. Sorry about my handwriting. We do not know E and F. It's here that I want to introduce a pretty handy equation, and it's on the front of your packet. It's that the probability of E or F is equal to the probability of E plus F minus the overlap. The reason this formula is useful is because, it says the probability of E or F right here, and we know we're not looking for that. This formula is used to find any one of these four pieces. So, for instance, we're looking for E and F, which means I don't know this part. But I do know these other parts. E is listed to be 3.5. F is listed to be 0.5, and E or F is listed to be 0.6. And if you combine like terms here, you can solve for the missing piece we were originally trying to find. So I would have to subtract here, that cancels. Subtract here to balance. And we know if there's a negative in front with no number, you can always pretend there's a -1 there. So let's just pretend we're dividing both sides by -1, and we find our missing piece to be plain old 0.25. So I put that back up here in the beginning and I add, and my answer, final answer, is 90%. So again, if you're looking for anything, either E on its own, F on its own, the sum or the overlap, which are the only real 4 options when you're given those 2 sets, use that equation and plug in 3 out of the 4. Example 5, I'm going to let the probability of any one of these events be represented by a W so that I don't have to write that PR part over and over again. And since all of these V's are contained in my sample set, remember the beginning portion of this said the probability of your sample set is always 100%, i.e. that is, some event in the sample space is bound to happen. And they all have varying probabilities, which we label with 1, 2, 3, 4, 5. And that's just because there are 1, 2, 3, 4, 5 events. And then it gives you some clues. It says that 1 is 0.1. Alright, anytime you can label with a number, use a number. And then the rest try to convert to be the exact same W. So let's see, it says that W2 is twice as likely as W4. 3 and 4 are equally likely. And 1 and 5 are also equally likely. So the one I see more of than any of these is W4. So let's see, if I let that happen, 2 becomes 2W4. 3 becomes W4. W4 can stay the same. And then it says 5 is W1, which might seem like a problem. However, remember what we replaced that with. That was just another number. Okay, so we combine those to get 0.2. And then we've got 2, 3, 4 W4. Subtract 0.2. We have no more like terms. And then divide by 4. And those 2 will cancel. W4 ends up being 0.2. And remember my spiel whenever I say we work these types of problems, it's write the equation, solve the equation, and then answer the question, which has it written in kind of a cryptic way. It has these commas. What I want you to take that to mean is to add the probabilities they are listing there for you, which is 2, 3, and 5. Okay, now we weren't given 2, 3, or 5, we were given 0.2, so just real quick, see if I can just list these, that way I make my plugin much easier. Okay, we knew 1 and 5 were the same, that one's pretty easy. 3 and 4 are the same, so we know this middle value is 0.2. And the last one is supposed to be 2 times that value, 0.4. 2 times 0.2 equals 0.4. So that'll go here, and then 0.1 there. 4, 5, 6, 70% will be our answer. On to the last one. It says the sample space has 5 different outcomes, and then listed with W's are the probabilities of those outcomes. And they give you 1, 2, 3, 4, but they don't give you 5. But if you just think, let's see, we have 10%, 15%, 15 plus 40, that's 55. 55 plus 15, that's going to be 70%. So if you think, okay, well, if 70% of it is here, then that means that W5 must be the additional 30%. Okay, now we have all 5 of them. Let's see if we can answer the questions. It says A, 2, and 5. So 2 we said was 0.05. 5 we just found. Final answer, add those two together. Pretty simple. 0.35 is your answer. Part B, it says the probability of the sample set. Well, this is what we usually get when we write out blah, blah, blah equals 1. So this is the probability of the sample set. So it is equal always to 1. Answer to B is 1. Part C, probability of 1, 3, 4 or 1, 2. Now, I want to again remind you of this formula we used earlier. This is going to be the probability of the first one plus the second one minus the overlap. So what that looks like is 1, 3, and 4 is going to be 0.1 plus 0.4 plus let's see, 1, 5. Okay, that's the first group. And then 1 and 2 minus, and you got to think, what's the overlap here? Well, they're sharing this value 0.1. Okay, so we just want to make sure we don't double count anything, and this avoids that. And your final answer here is going to be also 0.7, because you would get, let's see, 65 from here, 15 from here, that makes 80, minus 10. Okay, go ahead and try day 2, and I'll see you guys on Monday. Take care.